this lecture, we'll solve the problems on speed control of DC shunt motor and the problems on speed control of DC series motor. The most important problems and repeated problems we will discuss now. A 250 volts DC shunt motor has a shunt resistance of 200 ohms. This 250 volts DC shunt motor means the V is equal to 250, that is supply voltage is 250, and shunt field resistance of 200 ohms has an armature resistance of zero point 0.3 ohms. So RA is equal to zero point 0.3 ohms. For a given load, motor runs at 1500 rpm. For a given load, the motor runs at 1500 rpm, drawing a current of 22 amperes from the supply. So that current is called the line current. If a resistance of 150 ohms is inserted or added in series with the field winding, so this type of control is called the field control of DC shunt motor. So we are connecting a series field whose value is 150 ohms. Find the new value of armature current. What is IA2? This is N1 and IL1. And the speed is also how much? N2 is equal to how much? Assume the load torque is equal to constant, that is T1 is equal to T2. The magnetization curve is linear, that means BH curve is linear. Okay. So coming to this, first you should draw the diagram under case 1 condition. After that, case 2, for case 2 also you should draw the diagram. Case 1. So this is armature winding, and the field winding is connected in parallel with the armature for a normal DC shunt motor. The line current IL1 is given as 22 amperes, and the supply voltage is 250 volts, and the shunt field winding resistance, this RSH, is equal to 200 ohms, and armature resistance is 0.3 ohms. And with this, anyway, back EMF is also present. The current flows through shunt field winding is ISH, and the current flows through armature is IA. If you apply the KCL at this node, IL1 is equal to IA1 plus ISH1. So this is ISH1. ISH1 is equal to the same supply voltage will be appeared across the RSH. So V divided by RSH, 250 divided by 200 ohms, that should be equal to 1.25 amperes. So from this you can calculate IA1 is equal to IL1 minus ISH1. The IA supply current for a particular load, for this load is 22 minus 1.25. 22 minus 1.25, that should be equal to 20.75 amperes. As he is given in the problem, assume that the load torque is constant. So what is the meaning of load torque is constant? As T1 is equal to T2, and we know that torque is directly proportional to flux into Ia, and the flux is directly proportional to shunt current. So T1 divided by T2 is equal to ISH1 divided by ISH2 into Ia1 divided by Ia2. So if these two are equal and both are cancelled, the ratio is 1. 1 is equal to ISH1 Ia1 divided by ISH2 into Ia2. From this we can write it as ISH1 into Ia1 is equal to ISH2 into Ia2. So this is one of the important equation. You should remember one is clearly mentioned that the torque is constant. The torque is constant means torque is directly proportional to flux into Ia. So then after that, how we can calculate ISH2? See, this is a case 1 diagram is over, and coming to the case 2, if you want to draw the diagram, so this is the armature, and we are not changing the armature resistance by adding, that means we are not changing the armature part. We are not adding an external resistance in the armature. We are adding an external resistance, that external resistance value that should be equal to 150 ohms in series with the field winding. So this is RSH. The supply voltage also we can't change. Here the V is equal to 250 volts. And the current drawn from the supply now is IL2. The current which is flowing through this one is ISH2, and this one is IA2. Okay, so what is ISH2? The ISH2 is equal to V divided by, as these two are connected in series, RX plus RSH. V is 250 divided by RX is 150, and what is RSH is 200. So 250 divided by 350, that should be equal to 0.7142 amperes. Substitute here ISH1. The ISH1 value is 1.25 into what is IA1? IA1 what we are getting, the value is 20.75. So 20.75, that should be equal to ISH2 we are calculating by adding an external resistance in series with the field. So 0.7142 into IA2. So if we are calculating, the IA2 value is equal to 36.316 ampere. 36.316 ampere. So the new value of armature current we are getting. So what he is mentioned means the load torque is constant. Torque is directly proportional to flux into Ia. Then with this, okay, find out the EB1 and EB2. So V minus Ia1 into RA. V is 250 minus 20.75 into the armature resistance is 0.3. And similarly calculate back EMF 2. So V minus Ia2 into RA 250. The new value of armature current is 36.316 into 0.3. So in the first case what I am getting means 243.775 volts, and in the second case I am getting as 239.1052 volts. So we have one relationship. N is directly proportional to EB divided by 5, and N1 by N2 is equal to EB1 by EB2 into phi 2 divided by phi 1. So phi 2 is replaced with shunt current 2, phi 2 is replaced with shunt current 2, and phi 1 is replaced with shunt current 1. So now the what is the speed is N1 is 1500 rpm divided by N2. The EB1 is calculated just now. The value is 243.775 divided by the EB2 value is 239.1052 into the shunt current 2. What is the shunt current 2 value is 0.7142 divided by 1.25, then the speed I am getting the answer is 2575.024 rpm. See, this is a very important problem. This is a problem which is on field control method. You should observe the field resistance will increases. Logically, you can think in a shortcut method. What is a shortcut method means? The field current decreases, then the flux decreases, then the speed will be increases. See here, if an external resistance is added, in series with the field, the current which is flowing through the field will be decreases, the number of flux lines will be decreases, the speed will be increases. Let's check it. The previous speed of the motor is 1500 rpm with a shunt current of 1.25. Once the shunt current is decreased, as the shunt current is decreased, the value of shunt current is 0.7142, which is less than that of the 1.25, by inserting an external resistance in series with the field. So then obviously the speed will be increases. In overall conclusion, you can remember the formulas. EB is directly proportional to N phi, where N is directly proportional to EB divided by pi. N is directly proportional to EB divided by pi. And one by one you can calculate. You can go in a reverse manner also. First write down the formula of EB is equal to phi Zn by 60 into P by A. If except N and phi all other terms are constant, EB is directly proportional to N phi. N is directly proportional to EB by phi. So in this problem is clearly mentioned that the load torque is constant. That means torque is directly proportional to flux into Ia, and the flux is directly proportional to shunt current. That means ISH1 into ISH1 into Ia1 is equal to ISH2 into Ia2. So T1 is equal to T2. From this we are getting the armature current, and find out the back EMF 1 and back EMF 2 and substitute the speed equation. Then you will get the speed of the armature with an adding of an external resistance in series with the field. Okay, so coming to the next problem. So this is also very important problem. The problem on yes, DC shunt motor with external resistance is added to armature. So to armature. So this is our concept. The second problem is a 220 volts DC shunt motor with constant field drives a load whose torque is proportional to whose torque is proportional to speed when running at 1000 rpm. It takes 30 amperes. Find the speed at which it will run if a 10 ohms resistance 10 ohms resistance is connected in series with its armature. The resistance of armature may be neglected. So first of all, I am drawing the diagram. So this is a so I am giving the supply voltage is 220 volts. And it takes 30 amperes. That means Ia1, the armature is taking 30 amperes. This is Ia1 is equal to 30 amperes. So Ia1 is equal to 30 amperes. And this is RSH. What is the RSH value? What he is giving RSH value? Drive say whose torque is proportional to the speed when running at 1000 rpm takes 30 amperes. Find the speed at which yes, it is not at all given this problem. Okay, and we are connecting an external resistance, so that is 10 ohms. So 10 ohms, this is a field winding, is not disturbed. It is connected to 220 volts. Now what is Ia2? EB1 is equal to V minus Ia1 into Ra. So he is clearly mentioned that the resistance of the armature may be neglected. That means armature resistance is 0. So EB1 is equal to 220 volts. EB1 is equal to 220 volts. If the torque is constant, torque is directly proportional to flux into Ia, and the flux is not torque is constant, it is the flux is constant. Why? Because if you observe, the same 220 volts will be appeared across RSH here, and here also supply voltage 220 volts will be appeared across the shunt field winding. The same 220 volts will be appeared across shunt field winding. So then ISH1 is equal to ISH2. So that's why the flux is constant, that is phi1 is equal to phi2. Phi1 is equal to phi2. And is clearly mentioned that torque is directly proportional to speed. Then I will write it as N is directly proportional to Ia. N1 by N2 is equal to Ia1 divided by Ia2. So under normal operating conditions is given as 1000 rpm as N1. So from this equation 1000 rpm, I want to calculate the speed. What is Ia1? So how can I calculate the Ia1? So Ia1 is how much? That is 30 amperes. And Ia2 is also we have to calculate. then Ia2 is equal to, cross multiply this one, 0.03 times of En2. We have one relationship, n is directly proportional to Eb by 5 and directly proportional to Eb. Why? Because the flux is constant when you are going for the armature control. En1 by En2 is equal to Eb1 by Eb2. N1 is 1000 and N2 divided by Eb1 is 220. And what is Eb2 at the new value of current? 220 minus Ia2 into 10. This 10 is called an external resistance. The armature resistance is 0. So 220 minus Ia2 into 10, 10 Ia2. So from this 220 means 0.22, right? Yes or no? 0.22 N2. If you cross multiply this is 220 minus, what is Ia2 value? That Ia2 value, what I am getting is 0.03. So 0.03 into N2. 0.03 into N2. 220 minus 0.03 into N2. Yes or no? 220 minus 0.03 into N2. Then 0.3 or 0.03, yes, 0.02. Then from this equation I got it as so I will substitute here, so 0.2 or 0.03. So 30 divided by 1000 is equal to 0.03. Okay, and into 10, I am forgetting this, into 10, yes, 0.22 into 220 minus 0.3 into and 0.52 N2 is equal to 220. From this we are calculating N2 is equal to 220 divided by 0.52. So 220, I am calculating in Calc 220 divided by 0.52. So finally I get it as 423.076 RPM. So the final value of N2 is 423.076 RPM, revolutions per minute. So the revolutions per minute. So we'll discuss one more problem also. A 200 volts DC shunt motor with a constant main field drives a load the torque of which varies as the square of the speed, when running at 600 rpm. Its armature takes 30 amperes. Find the speed at which it will run and the armature current it will draw if a 20 ohms resistor is connected in series with the armature. Neglect motor losses. and RA. So this is a problem. What is the solution for this one? We will see now. A 200 volts DC shunt motor with a constant main field drives a load. The torque, which varies the square of the speed. That means torque is directly proportional to n square. When running at 600 rpm, its armature takes 30 amperes. Armature takes 30 amperes. So IA1 is equal to 30 amperes and torque is directly proportional to n square. Our supply voltage is 200 volts. Then you should draw the diagram. This is armature. The field is connected in parallel with the armature. I am not disturbing the field. So this is IA. The current which is flowing through this one is ISH. The current drawn from the supply is line current 1. In the second case, I am adding an external resistance whose value is 20 ohms. Then definitely the current IA2 is changes. The field current is same. Why? Because I am not adding an external resistance. ISH2 is equal to ISH1. The V value is 200 volts and this one is IL2. So I know the relationship torque is directly proportional to flux into IA and the flux is constant. In this problem the flux is constant. Why? Because ISH1 is equal to V divided by RSH and ISH2 is equal to V divided by RSH and both are equal. ISH1 is equal to ISH2. That means phi1 is equal to phi2. And the torque is directly proportional to n square. N square is directly proportional to IA. N1 by N2 whole square is equal to IA1 divided by IA2 whole square. IA1 divided by IA2. So IA1 divided by IA2. So this is the problem. We have one more relationship also. N1 by N2 is equal to EB1 divided by EB2. So where we are getting this equation? N is directly proportional to EB divided by phi. This phi is constant, right? Yes or no? Then N is directly proportional to EB. So from this I am getting N1 by N2 is equal to EB1 divided by EB2. So substitute here EB1 by EB2 whole square is equal to IA1 divided by IA2. So EB1, what is the EB1 value? V minus IA1 into RA. What is EB2 value? V minus IA2 into RA plus external resistance whole square into IA1 is 30 divided by IA2. But we know that in the problem is given that armature resistance is 0. So supply voltage is what he is given, supply voltage 200 divided by 200 minus IA2. The external resistance value is added is 20 whole square is equal to 30 divided by IA2. 30 divided by IA2. So from this so 1200 whole square is 40,000 divided by 30 into IA2 is equal to, if you cross multiply, right, IA2 into this 20 IA2, that is 20 IA2 whole square. If you expand this, finally I got it as 400 IA2 square minus 933.33 IA2 plus 4000 is equal to 0. Then finally I got it as IA2 is equal to 17.67 amperes. And one more thing is that 5.67 amperes. So this is the armature value of current, but but we should not take is the IA2 is 17.67. Why? Because if an external resistance is added, definitely the current will be, as R increases, then IA will be decreases. So then you should take it as IA2 is equal to 5.67 amperes. So substitute in the, yeah, equation, then you will get 600 divided by n2 whole square is equal to 30 divided by 5.67. So finally I got it as n2 is equal to 260.84 rpm. These are the most important problems with the field control and armature control. You should remember, so by solving this problem I think you can understand the first problem, that is the field control means is mentioned that the torque is constant. The second problem, torque is directly proportional to n. In third problem, torque is directly proportional to n square. So based on the given data you can solve problem. Okay, I think you understand, guys. Thank you.